Hello, everyone, and welcome to our webinar. Did OpenAI just kill vector databases? I'm looking forward to this session on the Assistance API. My name is Matt Brown. I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded. You're currently in a listen-only mode. You may submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a SingleStore webinar, heads up that we present weekly webinars on data and AI use cases and new technologies. And in fact, if you like this topic, then I'm sure you will like the topic we're presenting on Monday, which is, if you click to the next slide, you'll see how to chat with image data using the new GPT-4 Vision API. During this time, our team will showcase a live demo and code share on how to leverage that new OpenAI API to chat with images data. So if that sounds fun to you, feel free to register right now. The link is on your screen, bit.ly GPT4 Vision API webinar. There's also a QR code there that you can screenshot or take a photo of. That'll take you to the RSVP page. I'll also post this link in the chat in just a minute. Hope to see you there on Monday. But getting back to today's topic, FYI, we would love for you to try out the technologies that we'll be talking about today. In fact, anyone who tries today will be entered for a chance to win new branded AirPods Pros. All you need to do is click the link that's on your screen right now, bit.ly OpenAI Assistant Vector DBs Raffle. I'm going to put that in the chat as well. I know that's a long one. Or you can take a photo or a screenshot of that QR code. All you need to do is log into SingleStore. We've got a free trial if you're a new user, or log in if you've got an existing account. If you're already a customer or have an ongoing trial, we will check the folks who come in through that link throughout today's session, and we will announce the AirPods winner by the end of today's session. So again, I'll put that link into the chat in a minute. We'd love to answer any questions that you have today, so feel free to put them into the Zoom Q&A. We'll keep track of those, try to answer as they come, and also we'll flag some for the end, live Q&A at the end. Let me introduce our speaker for today. Madhukar Kumar is our Chief Developer Evangelist at SingleStore. He originally has a background in software engineering. More recently, he has led product marketing and product management teams in the cloud data industry. Welcome, everyone. Madhukar, the floor is now yours.
All right. Thanks, Matt. Just a quick check. Can you hear me okay?
Sounds perfect.
All right. Yeah, I've got this new microphone I'm trying out, so hopefully it will cancel out if my dog starts to bark in the background. Happy Friday, everyone. As Matt said, we have been talking about and we have been playing with vectors as well as large language models, I think starting about February of this year. And every week there are some exciting things and exciting changes and new developments. And I think over the last few months, there are some things that have stayed stable or some things that have not changed for a while, till, of course, OpenAI, when it announced on its dev day, which I believe was last Monday, which is what we're going to talk about. And I agree it's a controversial topic in the sense, does it, whatever OpenAI announced, does it obviate the need for a vector-only database, or do you still need it? And that's what we are going to explore today. So one thing that has been constant for the last 8 or 9 months is large language models. They are frozen in time in the data that they have been trained on. And that was true till at least ChatGPT was trained till September of 2021. But in Dev Day, Sam Altman announced that now ChatGPT4 has knowledge up to March of 2023, which is great. So you now have a more up-to-date context, but you also have a much larger context that you can send it. So till earlier, I think it was only when you're chatting with ChatGPT, you could send up to 8,000 tokens. So one token is roughly about 1 character. So you can think of it as, that many, if you do the math and divide it by the total number of characters in a word, That's effectively how many words you could send. That increased to 100,000 context with Claude. And then in the OpenAI announcement, now ChatGPT can take up to 128,000 tokens, which roughly corresponds to about 300 pages of text. Now we'll get talking about how effective it is, how much it's going to cost, and all of that other stuff. But for now, even with the larger context as well as the update of the training data, it still doesn't know the data you have, right? So what do I mean by that? If you're working for a company, you have petabytes of data and terabytes of data, and that consists of data that there is no way an LLMs, and specifically commercially used LLMs, will have knowledge about, because it has not been trained about it. It doesn't know that that data exists. And if you're doing an LLM application, you have to make your LLM aware of that data. So even today, there are 3 different ways you can potentially make that LLM aware of your data. First is you retrain your large language model. And that actually is not a very easy thing to do because it costs millions of dollars. It requires GPUs. And it's like a mental wipeout, in the sense you wipe out the parameters and the weights from the LLMs, and then you refeed it with your large data set, and you build out the weights, and then you do your own training to it. So it's almost like recreating an entire new LLM. And it's not for everybody, but there are still companies that are doing that. Bloomberg, for example, they created their own GPT, and it's based on their data. The second option is fine-tuning an LLM. And fine-tuning, if you use something like a Vertex AI from Google, you can do it fairly simply, in the sense you look at the existing data set that the LLM might have, and you incrementally give it more instructions with the query and response. And then you say, hey, if you see any additional queries like this, I want you to respond like this. So it combines a little bit of reinforcement learning with human feedback, RLHF, and it fine-tunes the LLM for a specific behavior, which in effect means it doesn't mess with the existing weights and parameters, but it does add specific behavior to your LLM. But the one that has really taken off is called retrieval augmented generation. And retrieval augmented generation, what it basically does is it gives the context of your data to the large language model when somebody is querying it. So it's literally like the way I describe it. Let's say your LLM is an extremely smart or a genius child, and it's a prodigy and knows and can answer questions about all the data it knows about. But if it doesn't know about your family history or family tree, and you're asking a question, who was your grandfather, for example, you basically go to your library of your data, you curate that data, and then you give it to the LLM and say, you're great at doing this, now read this book and answer my questions. And that reading that book or that context is that context window, which is now fairly large. So you can literally give it a 300-page book. So if I were to draw a simplistic diagram of what it looks like for a generative AI application, it really boils down to this. Your end users is asking a question or sending a command or doing information retrieval to your application. And this application has its own architecture, which I'm going to talk about a little bit. And this is all your company data. And this is probably the understatement of the century, because this company data doesn't look anything like this, and I'll explore that as well. And so what you do is you search that corpus of data or corpora of data, you retrieve that context based on what the user is asking, then you turn around and give it to the LLM and say, hey, answer this question. That in effect is what retrieval augmented generation is. Now, it turns out when you do this, a lot of companies starting about 6 months or so, they realized, oh, if I have to do this, I actually need a vector store or a vector only database. So the examples here could be all the way from, excuse me, all the way from libraries like FAISS, FAISS, which comes from Meta or Facebook. It also includes Annoy, ANNOY, which was created by Spotify, and SCAN, SCANN, which came from Google. Those are the three big vector stores. And these are libraries, so you can import it into your Python or whatever backend you're using. And in effect, you can give it the data. It uses that data to convert it into a vector. And then it does a vector search against it before it sends back to the LLM. So what's the problem with this? Well, the problem is, as I said, the understatement of the century is what the company data typically looks like. And I have worked in several large and small companies, and I have nowhere worked in a company, however small it is, that only has one database. It has typically, you would have MySQL, Postgres, maybe you'll have MongoDB, and then that's typically for your transactional database because you're storing transactional data. And then you're doing like a very high throughput and a very fast write. You're not necessarily reading it. But if you want to do, let's say, some sort of analytics, and you want to see, okay, how many users came into my platform, or how many products did they purchase, and what does my revenue look like in the last 6 months? Turns out OLTP is not a good way to do all those analytics because it requires you to do aggregations. It requires you to do sum, average, those kind of very basic things. So a new kind of database emerged, which is OLAP, or Online Analytics Platform. And there's, of course, there are variations to it. There's a data warehouse, which is used for just storing data. There's a data lake. Actually, data warehouse is where you do some analytics processing, but data lakes is where you just keep the data. And this is stored in a columnar database, right? So you store it in a way that is far more optimized for reading and doing analytics. So this, by the way, is your structured data. This could be in JSON or it could be SQL, and this could be in mostly SQL, it could be in Parquet, it could be in CSV file, it could be in object stores, a bunch of different ways. And you're constantly ferrying the data between these two using something called ELT pipelines, or extract, load, and transform. You have scheduled jobs where you're picking up the data, you're doing some processing on it, then you're loading it and then transforming it. But you also have a much bigger corpus of data, which you want the LLM to know about and be really useful in answering those. And that could be your customer support tickets. It could be sitting in Zendesk. It could be documents that might be sitting in your file system, or it could be inside of Google Drive. There could be your private repos. It could be Slack. And you want to use all of that. So when you add a vector-only database, you're actually ending up doing a disfavor to the company and yourself, because now you've added more latency, more data movement, and you are actually causing it to be a little bit more expensive. So first and foremost, why do you need a vector-only database? And turns out the reason why we needed a vector-only database, or vectors, is because you use that for semantic search. So let's talk about what is semantic search. Semantic search is a meaning-based search. So there are basically two broad categories of searching. There is a keyword match where I can say, hey, my sentence is, Huskies are dogs from Alaska. And if I asked, or if I did a search, which is an exact keyword search or a lexical search, the question would be, is there a dog in the sentence? So it looks for exact characters D, O, G, and S, or DOG. And if the answer is yes, then you get back a yes. So if you remember the Google Drive and the Dropbox and the other searches in the past, it is based on exact keyword or lexical. And it's horrible because sometimes, you don't get the exact keyword, or there might be a typo and the answer comes back as negative. But you do know that there was a file, something related to it, and you don't know the exact keyword. So it's okay for certain use cases, but when you're trying to search a very large amount of unstructured data, then it's probably not. Semantic search, on the other hand, says, well, is there an dog in this sentence? The answer is, of course, yes. But you can also ask a question like, is there an animal in this sentence? And there's no use of the word animal or even canine. But what it does in the semantic search is it stores all of that unstructured data as what is called vectors. And vectors are basically, the easiest way to define it is, if I'm storing a data inside of a vector, I have a latitude and longitude of the exact location where it's stored, except latitude and longitude are only 2 dimensions. You can think of 1,000 dimensions in a vector, and sometimes even more. Now, the key secret sauce of semantic search is when you store a data, at that time, you figure out which words are similar to each other. So huskies, dogs, canine, beagle, the one that you just heard barking in the back, all of them are closer to each other. So their vectors, numbers are coded with the exact distance between. And so when I do a semantic search, it finds out whether a dog and an animal are close to each other. And if the answer is yes, and the distance is less than 1, then yes, it's a meaning-based search, and that's how you get it. So how do you use it in a large language model? Typically, what you do in a RAG use case or retrieval augmented generation is you first create the vectors. So what does that mean and what does that look like? Typically, it is done, let's say, in your code. It could be done in your Python, or if you're using JavaScript, Go, whatever you're using. You use a library or an API to create the vectors, which is also called embeddings. So if I were to create a sentence called Huskies are from Alaska, I would take that as an input and I give it to a model called BART, or OpenAI embedding model. And return, it will give me back 0.11234, comma, 0. minus 0. whatever. So it's a bunch of numbers separated by commas. Then the next thing you want to do is you take those vectors and then you store it inside of a database. Or you could store it in memory, which is where the free libraries or open source libraries are used. And that's where you have things like face, annoy, or scan. But when you store the vectors, you also want to, just like a database, you want to index them so that they are optimized for both storage and retrieval. So that's where, you know, the algorithms come in of how you store it and you retrieve the data. And when you search that, there are 2 primary, I would say, big algorithms that you can use. One is called the cosine similarity. Cosine similarity is, if I have 2 objects, what is the angle between those 2 objects? And the smaller the angle, the closer it is to each other. And the other one is Euclidean distance, which is the exact distance between the two different vectors. And then there are a few others. So one question to ask is, why did this suddenly blow up in the last 1 year? And the reason for that is, when OpenAI created or announced its embedding model last year, it was really good in the sense, when it created vectors from existing data, it really had a good algorithm to know which one's closer to each other. And that's why people said, okay, let's just start using that. But in all fairness, now there are some better algorithms, like BART from Hugging Face, BRT, not BRD, is really good. So at this point, what I would do is I'll step back and say, what are the major use cases for LLMs? And in my mind, from my perspective, I'm seeing 2 different big categories. Now, of course, this is my opinion, so you can always use a grain of salt with that. And I know when we posted this on LinkedIn, there's like wild comments and controversial. Obviously, people are saying, no, you still need a vector database. And others are saying, yeah, maybe you don't need it. So this is my opinion of what I think is going on, right? So if you think about it, that the world is divided into 2 big use cases or categories. The first use case or the first category is new startups small to medium businesses, independent developers, mostly around B2C. And these users are trying to build LLM applications, but incredibly fast. And they want to do it with the least amount of cost and the least amount of effort over it. But what are some of the use cases? Well, the use cases is custom chatbot. Matt and I, we were just talking before this call, is I might have a custom chatbot that does SEO audits or improves SEO based on some existing content. The second one, which in my mind has been the most common, is some sort of an information retrieval over custom data. So this would be a custom chatbot. We have one for SingleStore. It's called SquirrelBot. It knows about our data. So when you ask questions, it basically does a semantic search and gives it to the LLM, OpenAI in this case, and then tells you, here's the answer, but specific to our data. And the third one is you're just doing Q&A over custom data. I wrote an app like 4 months ago using Streamlit, where you upload PDF and then you just ask questions. And if you're interested in that code, let me know, I can share it. But now, of course, there's like a dime a dozen. There are millions of, well, not millions, maybe hundreds of applications that allows you to do that online. You just upload your PDFs. And if you're a researcher, if you're a student, or if you're just trying to get a quick summary of what a very large document could be, it could be a 10K or a 10K document of a public company or something like that. And you can just ask questions over it and it'll tell you. But in the B2B enterprise use cases, which is the bigger ones where you have 6, 10, 15, 20 petabytes of data, you typically have use cases where you want that LLM to know about of that data, or at least be aware of that data. 2, they could be custom actions, like you're not only doing Q&A, but you're taking the recommendations back from the LLM and doing something with it, which could be send a Slack message, go make an investment decision, or make a recommendation to a support agent who's talking to a customer. And there are other requirements, like if I have very highly confidential documents, which not everybody is supposed to read, then how do I make that RAG-based use case compliant to security? How can I audit? And how can I do data governance? But there are use cases, at least from SingleStore perspective, we have customers who have been using our vectors since 2017, because we've had vectors since 2017. Unlike a lot of the newer vector-only databases that came in like this year or maybe 2 years ago, we have had this, and that's what I'm going to talk about a little bit from now. They've been using it for anomaly detection. They've been using it for cluster and classification. And of course, if you step out, you can also use it for code generation, translations, and whatnot. So you're building some meaningful applications that has a moat around it. And what is that moat? What makes that different? I'm going to touch upon that too. So let's look at the first step of, let's say I'm an independent developer, right? And when I wrote that PDF document Q&A questionnaire, I had to do these steps. I basically first took the entire data that I have, a PDF, I parse it, I remove the images, I remove the special characters, and then I tokenize it, then I chunk it. And I chunk it by saying, if the one paragraph is one chunk, then the next paragraph is another chunk. And each chunk is then converted into some sort of a vector. But I could have other strategies too. I could say, no, I need the entire 2,000 word, summarize it, and keep that summary as a vector as well. And then for each paragraph, I'm going to create vectors. And then I'll have an overlap of each one of these. And the other strategy could be that I actually have the summary as categorized, and I could have summary of the document. So it's called MapReduce algorithm. And then I have a vector of those summaries. And I could do all three as well. So there's a lot that goes into this. And especially if you're an independent developer or SMB, that's a lot of work. And it costs money because every time you go create an embedding, unless you're using a free open source one, then the next one is storage. So this is where the likes of all, vector-only databases show up. And there could be Milvus, there could be Pinecone, there could be Quadrant, there could be Superbase. There's a bunch of these, right? But in addition, all the other existing databases also have vectors. So traditionally, you can actually store this even in PGVector, which is a plugin for Postgres. So vector is no longer just a differentiator. You can have vectors in the database that you might be using. In fact, Mongo has one. In fact, Neo4j, which is a graph-based database, also has vectors now. And then finally, you do searches, and the searches is based on, your basically existing algorithm, cosine similarity, or the distance match. So when I'm doing this, there are two big open source libraries that have emerged over the last few months that has made this easier, but there's still a lot of coding involved. And one is LangChain and the other one is LlamaIndex. With LangChain, you can, with a few lines of code, you can read a document, you can tokenize it, you can chunk it, you can then basically create vectors out of it, and then you can do retrieval out of that. And then there is, and LangChain has a connector to SingleStore as well, by the way. And then LlamaIndex is primarily around retrieval augmented generation, where it's even easier. You can use a bunch of existing connectors, again, SingleStore being one of them. And you can just primarily swap out the LLMs or swap out the vector storage, and you manage all of this in the application layer. But what happened last week was OpenAI, in my mind, approached the first category of use cases with two different things, or maybe the second one is for a different use case. And I'm happy to show this very quickly. So what they announced is called GPTs, and GPTs is custom chatbot. And in that, you can create your own GPT, which is custom to your data, which is custom to your instructions, and it is custom to your actions. So we'll double click on that to say why that is so, so important. But in addition, and that's a no-code tool, by the way. But in addition, they also created, or they announced a programming version of it, which is called Assistant. And in Assistant, you can also do the exact same things. You can choose a model. You can choose the existing tools that OpenAI has already created. And that includes the code interpreter, the retrieval, which we'll talk about, functions, and even DALL-E. So you can generate images and stuff. But what is important is that for both of these, when you use the no-code version or the code version, or the assistant versus GPT, you can now upload your own files. So what does that mean? Well, what it means is that, remember earlier, I could have to go and use LangChain and LlamaIndex if I'm building a very PDF Q&A question type. And then I will go in and deploy that code and do all of that. Now I can literally go to GPT. I can upload my PDF files here. I'm happy to demo that if anybody is looking to see it. And what OpenAI does is it will create embeddings of vectors out of it. And it's apparently very good because we know they kind of brought this revolution around how large language models are stored and you retrieve data from it. And you don't have to write a single line of code. And it basically uses semantic search in the background to first retrieve your data. And then you can use it as a knowledge base for your custom GPT. Similarly, what I can do is, even in assistants, I can add as many files. And in this example, what I've shown is I uploaded the SingleStore Cloud, which is a document that we have for SingleStore best practices. And now, I'm calling the SingleStore Guru. Now, if I ask questions, firstly, it's going to look at this document and then answer. And I can do this all with an API endpoint. Now, what's interesting is that, in my opinion, again, these are the building blocks of artificial general intelligence. Because if you look at how humans behave, we consist of three things: our memory and our knowledge, our skills, which is based on actions that we have done over a period of time using that knowledge and memory, And then we have specific skills that we can do that is differentiated from others. And third, which may or may not be true for human, is we are all wired for certain things differently. Like I am wired for maybe writing an article or learning or something like that. And Matt may be more wired for, I don't know, playing the guitar or any musical instance. So if I take all three of this and I add custom knowledge, custom actions, and custom instructions, I can literally personify this in a physical object. And that becomes, in the near future, AGI. But the key part here is there is a no-code version of it and there is a code version of it. The code version of it is, I don't want just one agent or one assistant. I want a swarm of these all doing different things, and I want them to coordinate with each other. And then they go figure out and learn by seeing as well as hearing stuff, just like humans, build their own knowledge. And then based on knowledge, they create actions, and those actions are specific skills. And then whatever your instruction is, like if you're a fan of Asimov, he talks about how the first instruction could be, you will never harm any human, period. And these are just the tenets that it stands by. And these are like the things that hopefully will make it more safer for us. So when we are thinking about a retrieval tool, there are a few things to note, right? Which is when you are using the retrieval tool inside of an assistant AI for OpenAI, according to their site, it costs 20 cents per GB per assistant per day, which means if I'm storing 1 GB of data in those retrieval files, that's $73. And you can do the math if you use Dropbox, for example, I think it's $18 a month where you get 3 terabytes of data. But we're talking of two different things. But I have not 1 GB, I have petabytes of data. And if I'm doing a no-code application, maybe I can bite the bullet and I can use it for a while. But if it's a really large data set, this is not the tool for me. Then, of course, you would need a vector and a vector-based RAG or retrieval augmented generation. Second, once I've uploaded a file, what happens if I have a new version of that file? And you have to go back and basically remove the old one and add a new one. By the way, LangChain also created something very similar in its open source version. And I think it'll be far more powerful when it's completely done. And that's called OpenGPT. So you can go check it out and you will see that there it's a lot cheaper because you can run it on your own and you can choose your own algorithms and it has a lot more control. And number 3, I would say, is right now it's only unstructured data, right? So I cannot give it a SQL file. I can give it a CSV file, but that requires manual work. But here in the enterprise world, you have to worry about cost. Like, how do I create, store, embed? I need to do incremental updates because if I'm an e-commerce engine, my transactional data is coming at an incredibly fast rate. If I'm looking at the logs of my network and I'm using that to do security anomaly detection, that's coming at an incredibly fast rate. And all of this, I need it in a few milliseconds. I cannot wait for Pinecone or whatever to do the incremental update and then wait for 15 minutes to get converted into vector. And then I go do a search. By that time, that incident has already happened or somebody's already walked away with the money. And I also need not just structured, but unstructured both at the same time. I need to be able to look at SQL plus JSON. More importantly, I not only need vector-based searches, I also need lexical at certain point. And this is the example demo I'm going to show you. Because let's say if you're looking at a movie and a movie recommendation, if I just did a movie recommendation of, French movie that I like to watch today, it's just going to do a similarity search. But if it's specific to me, it's going to look at my user data, which is in a SQL database. It's going to look at what movies I've favorited. Then it's going to zero down to that. And then it's going to do a keyword search. And then it matches with the vector similarity. And then it re-ranks it. That's a real use case. And there you need a contextual database. You don't need a vector-only database. And the last thing is you have to keep moving the data around, or, otherwise, if you are doing vector-only databases, you are constantly doing ETL. You're constantly trying to figure out which data is going to stay in vectors. How often do I need to update it? And what happens if that data disappears? All of that other thing that you need to worry about. And if you look at the enterprise use cases, this is the emerging architecture that I've seen over and over again, which is you get 3 different layers of it. The data layer is a pretty elaborate layer, which includes SQL, JSON, your data lake, Slack, PDFs, unstructured. You probably need a thin layer of vectors over here. You need some sort of a compute on top of it because you want to do some compute right next to the data. And then this is your decision-making layer, which is similar to the human's prefrontal cortex. And this is where you have agents. You could have several different large language models. And then finally, you have your receptors and effectors, which could be audio video interfaces, or today it is just chatbot or typing, but it could very well be glasses that takes pictures or listens to me through microphone and then is constantly giving me that feedback by running all of this. So this is where it gets a little bit into SingleStore. And of course, this is a shameless plug, but I also feel if I was not at SingleStore, I'll still be talking about it because all the use cases that we just saw is actually been doable in SingleStore since 2017, because not only it has JSON, not only it has SQL, not only it has analytics and transaction, it has had vectors with a dot product function since 2017 when Google wrote the first paper on the transformers. So what is it? It can create row-based data, which happens to store in memory, which is why it's in few milliseconds. It can do columnar storage as well. You can choose that at the time of creation or over a period of time in usage, it converts into it. And you can do semantic as well as keyword search, both. But all of that is happening in a few milliseconds. So if I were to boil it down into one single SQL statement, and this is what we'll see today, is in one single SQL statement, I'm mixing and matching different kinds of data, which could be the user data, the transactional data. I am doing a dot product, which is a semantic search, and re-ranking it. I'm combining it with analytics, which is a columnar database. And all of this, I'm getting back over 20 million or maybe even more records in less than a second. This is the building block of a real-time AI, because now if I'm doing real-time AI with audio and visual, I can't go back to my 10 petabytes of data, do a first convert part of it, and then put it inside of Pinecone, and then I wait for it to get updated. Then I make a semantic search. Then I go back to that data because Pinecone or any vector-only database can only store vectors with a 15 KB limit on the metadata. So I now have to go back to my previous data source and then go look for that metadata and go do another retrieval. By the time it's 15 minutes, not 1 second. So I'm going to skip all of this. The only thing I do want to call out is you should check this out because we were known as MemSQL. And at the time when we were founded, there were only 3 in-memory databases at that time, MemSQL, which is SingleStore now. There was Memcache, and then, of course, there is Redis, which I've also had the privilege of working with a few years ago. And any data that you store goes first into row-based in memory, then it goes into persistent local disk, SSDs, and NVMEs, and then finally into cloud storage. And we have customers that use this architecture to build the world's largest identity graph, and that is through LiveRAM. And they do 2 terabytes of read and write just from the object storage. So I would say go check it out. Again, I don't want this to be pitched, so I'm going to skip this. You can go check out our website and see what we can do. Now, one thing that we did add, which I am incredibly excited about, is called notebooks. So if you're a programmer or even if you're a data scientist or a data analyst, what you typically want to do is go to your data and then run your code along with that data. So typically Python is great for it, Pandas is great for it, Scikit is great for it. So you have to go create your Python, and then you typically run it inside either a Jupyter that's running locally, or you can go to Google Colab. So we added this as part of SingleStore. And within SingleStore, which is what we're going to see, you can go get started, and then within a few seconds, you can do something like this. More importantly, we also have Squirrel Bot, which will generate this code for you as well. All right, so how do we get started? Let's walk through the use case. First and foremost, I wanted to show you that if you were to build a GPT of your own, if you can see my screen, I'm going to make it bigger before somebody complains. You would go here to explore to look at all the other GPTs. By the way, if you're wondering what a SingleStore is, we will see that in a future upcoming webinar. It's incredibly exciting. So here I would go to, let's say, explore, and I say create a GPT. And you can create a GPT by giving it instructions, but you unlock a little bit more when you go to configure, and you can check these so that your GPT is able to browse the web. It's able to generate images. It's able to do data analytics. And in addition, what you can do is you can upload your own files. This is the retrieval part that we just talked about. And when I do that and I upload, several PDF files in a no-code solution, I'm kind of done. I didn't have to go into downloading LangChain or building the whole retrieval code. So it's a very specific use case. I'm not saying that it obviates all vector-only databases, but for certain use cases, it now opens it up to people who just want to do it in no code. If, on the other hand, you want to do this in a coding way, then they have something called assistants. And within assistants, again, you could give it a name, you give it custom instructions, you can choose the model. This is the new one, GPT4 1106. That's the date it was released and the preview. You can add your own functions. So I can add my own APIs, endpoints, as long as it conforms to the OpenAI API JSON. I upload my own files, which is SingleStore cloud.pdf over here. And in essence, if I were to go try this out, it would be so this is my assistant. I can call it through an API. And I already just did it. I just asked, what is this document about? And it just reads the document and gives me the data. Now, with these two, again, I can build an entire stuff without code or very few lines of code, right? Depending on your use case. And what used to be is that for every single time, I would have to go sign up for a vector-only database, and I have to go vectorize and all that. So you get the idea. So what I'm going to show you right now is if you go to singlestore.com, and in fact, you sign up for the SingleStore by just going here and just, I'm already signed in, but you could just follow through this. And then you follow the steps to create your own workspace. Workspace, think of it as a disaggregated compute and database. So whenever I create SingleStore, these are my databases that I've created. And this is the compute. This is where I run all the SQL and so on. But let's talk about the notebook that I created. So in fact, I would say the best way to get started is if you go to this site called singlestore.com/spaces. And when you go to spaces, what I'm going to do is I am going to look for this thing called movie recommendation. And in the movie recommendation, this is a free notebook that anybody can use and download and see. And feel free to use this code for your own commercial as well. And then click on try it now. And when you try it out, you can either log in or you can do sign up. I've already done that. So when I do that, I come to this place, which shows me all my workspaces. It shows me my database and stages. Stages is a new thing that we have added. Again, very exciting thing that it's a no-code version of importing your data into SingleStore database. I'm going to show this at a later point. So let's go through what it's doing. First, We install the required libraries. This is where the sentence transformers are being used. We'll be using it for creating embeddings, but we are not going to use anything that costs us money. Here, I just create a database called Movie Recommender. And actually, you would see it here. My workspace is this, and the Movie Recommender is the database I am in. So now I can actually run SQL directly in here. I've created a bunch of these tables. As you can see, once I click on it, it runs right here. It tells you when it was running. So now I've created a bunch of these tables, which is movies, and I imported the data from a CSV file, which is sitting on S3 in Amazon, but I can keep it on Stages as well, which is local to this. I check that all the data has been loaded. You can see here that we have, if my math's right, 1 million rows here. Not a big data set, but you get the idea. Then we look at vectorizing the data by using this model. This is from Sentence Transformer. And then we use data frames. So let's go and look at what does the vector look like when you've converted some data to a vector. So it could be, as you can see, a movie ID, a title, genre, tags. So this is structured data. Now, when I vectorize it, in the same table, I am also storing vectors. This is the key difference between this and any vector-only database, because now I have the vectors and the structured data, and I can also mix and match with others. So what I'm going to do now, this is where my entire thesis or spiel about why you don't need another vector-only database comes in. So here I'm saying, hey, one of my favorite movies is Pocahontas. And based on that, I do some sort of a query. Now what I want to do is I ask a question saying, show me some, and these are some of the favorite movies I've put in just to seed the data. And now my question could be, show me a French movie that I might like. So that requires you to do a match between title, movie, vector. It does a join. It mixes and matches other parts of that data. And in essence, what we are doing here now is, as you can see, also running a similarity search here. So not only I'm doing a keyword match, I am doing a mix and match of data. And by the way, because SingleStore is also compatible with MySQL protocol, wire protocol, as well as MongoDB's API and Mongo SH. As you can see, there is a Kai shell, so you can just run any Mongo API compatible command here as well. I can mix and match the SQL, the JSON, the geospatial, the key value. I can do a vector search directly in there. And then I can do a re-ranking all in one single SQL. And basically, that's how I get my result back. And these are the recommendations that come back. So once you've done this, you've executed this one by one, you can go and then drop the database. If I were to show you what this table looks like, I can basically go here. I can go to the database and let's look at the movie recommender. These are my tables. And if I were to look at the vectors, let's say the sample data, this is the movie ID, the title, the genre, the tags, and the vector, because it's stored in as a binary. And that's why it's in memory and extremely fast and accurate, because it's an exact neighbor search. And you get all of this together. So you can literally go either look at this, or you can go back to the gallery and look at the other examples that we have, one for even OpenAI, one for Kafka and others, and then you can just go start playing with it. All of this, by the way, is for free. When you sign up, I think we give up to $600 of free. And we have a free tier coming up pretty soon, which would be free for life. So anyways, that's pretty much what I had to show. I'm going to stop sharing and see what kind of questions do we have.
Yeah, we've got more than enough questions that we can probably answer during the session. I've left a lot open for you to choose from, Madhukar, in the open. I've answered as many as I could, but a lot were beyond my scope. So I'll let you take your pick.
Yeah, so I'll just go from top down. Would you please elaborate on how we can differentiate in using fine tuning versus RAG? Looks like using both may be the best option. Any thoughts? Yes, you're absolutely right. They are both complementary to each other. As you see in GPTs and Assistant, you do both. You're fine tuning it in some way by giving it custom instructions and functions. And you're also using RAG because you're uploading the files and it uses that. The next one is, what if my vector DB doesn't return or doesn't take account of other related data even after prompt engineering, which is needed to get the actual analysis? LLM in such case, won't be able to curate proper response. Yes, that is correct, which is why retrieval is extremely important, and retrieval across multiple kinds of data is needed. It doesn't have to be just vector only stored that you put it in. How do you deal with temporal information? Example, APIs that come into existence and then get retired, feature or products that are offered and then retracted, Google, Wave, etc., in these RAG encodings. Very good question. I personally would use an assistant at that point, or an assistant API, and I would have my own API endpoint that would constantly keep a catalog of services that are up and running. And again, you can build it in multiple different ways. There are other ways to architect this as well. I'm just thinking of it in 2 seconds. Does semantic search use cosine similarity or another vector matching algorithm? Semantic search typically has 2 kinds. One is cosine, the other one is distance. And within SingleStore, for cosine similarity, you use a function called dot product, which is what we just saw. But you can also use functions for Euclidean distance, which will give you the exact distance between the 2 objects, and then you can do whatever you want to do with it. Do you think OpenAI uses vector databases or something similar in the background to store, search these embeddings? Yes, 100%, absolutely. In fact, I will say that I read somewhere that Elon Musk's new LLM called Grok, it uses Quadrant, which also happens to be a vector-only database. So something to think about. If we upload our documents, then there might be data leakage, right? Which is going out of my organization. That is correct, which is why you could potentially, if you're using OpenAI, you can use it in Azure, which might give you a private version of it, but costs money. Or you would use something like SingleStore, which would be in your control, your VPC, and you would be using RAG over there. Let's see. What is SingleStore Spaces? Something like Hugging Face Spaces, where you share deployed apps? Yes, that is absolutely right. Today, it is open source version, I would say, for all notebooks. You can go download it, use it for free, connect it to SingleStore, or start using it right away. Eventually, if you were part of the SingleStore Now conference where we announced, this will be a place where you would be creating your apps and you would be using to share it with others as well. And we also have a SDK called Elegance SDK, which you can use to build real-time AI applications and real-time analytics applications. So go check that out as well. Can OpenAI make a function call to SingleStore APIs? Yes, 100%. You can make any call to any other APIs. And SingleStore API, by the way, also gives you row-based RBAC. So you can control the data access at the row level using the APIs. And the way you call it from OpenAI in Assistants is, or even GPTs, is when you create your API endpoint, and that API endpoint conforms to the OpenAI API JSON schema. I was exploring Solar recently as it is open source. Any main reason that would give me a trouble later? I would say it depends on your use case. If you're only doing keyword match search, then sure, Lucene, Solar, they're all great. If you're looking to do both, which I think you should be, both keyword as well as semantic, then look at places or look at databases that can do both keyword as well as semantic and can store both unstructured as well as structured data. How would SingleStore compare with the capabilities of Microsoft Fabric? This is a much longer and a deeper conversation. I'm happy to talk about it. There are a lot of similarities and a lot of differences between the two as well. The one big difference is that SingleStore is both transactional as well as analytic, as we saw, and it is both in-memory as well as object storage, and it supports both SQL as well as JSON. I am not too sure about Microsoft Fabric and what are the other data types it also supports, but we also announced something called Aura, which is a custom compute layer, which allows you to even run things like Presto and stuff on top of SingleStore. How do you manage having to re-embed your data when changing LLMs? It feels costly and cumbersome. I would say that is one of the topics I want to cover in a webinar of the future. And the way to do that is we have a new feature within notebooks that will, and it's coming soon for GA, which will allow you to schedule a notebook anytime you want to run it. So one way to do this would be that notebook could be potentially looking at webhooks or even changes to CSV or Parquet files. And when those changes happen, the notebook runs, converts that data into embeddings, and goes and updates or does a CRUD level operation on a SingleStore vector table, and it keeps updating on its own. And there are ways to keep the cost to almost zero because you might be using open source embedding library, or you could be using your own custom scheduled job that might be running in your own infrastructure. It's totally up to you. Can I do the movie recommender using the SingleStore components under GPTs or assistants? Let me see, what does that mean? Can I do the movie recommender using the SingleStore components under GPTs or assistants? Yes, only if you take that notebook and convert it into an API endpoint, which conforms to the OpenAI API JSON schema. Can we use SingleStore for PDF documents and then get the RAG and response generation? Yes, 100%. And these are some of our very large customers who are doing exactly this for auditing data or auditing PDFs, as well as also making investment decisions for very large financial investment companies. For a purely tabular data, what is the value out of SingleStore as compared to something like PGVector, which also stores embeddings along with other columns in the PG PostgreSDB? In this case, if you're only using tabular data, I would say the difference comes down to performance and scalability. Because SingleStore is in memory to begin with, you can look at the performance metrics, by the way, in the TPCH and TPCC benchmarks that people have done. If that is a concern for your use case, then I would look at something like a SingleStore. If you're looking to do, more enterprise grade, then that's where I would go. If you're looking for a cheap or a free version and scalability is not an issue, then yes, PGVector with Postgres works great, and other databases with vectors, they work great as well. Which companies are fastest with adopting these integrated techniques? What are the best real-life use cases you have seen that are generating revenues for companies today? Two that we just talked about would be just going over the PDFs and Q&A and then using it to create custom actions, including things like, investment decisions. How do we get the recording? I'll leave that up to Matt. I think he's going to share it.
Yeah, I'll share it. Everyone will get it by email.
All right. I think we are out of time.
Yeah, Agreed. Okay, one quick note before we announce the Apple AirPods winner today. As I mentioned during the intro, we're going to be presenting another webinar on Monday, very related topic, how to chat with image data using the new GPT-4 Vision API from OpenAI. So during that time, we're going to showcase live demo and code share on using that Vision API and chatting with that type of data. If that sounds fun to you, I put the link in the chat, so check that out. It's the bit.ly GPT-4 Vision API webinar link. So check that out. Hope to see you on Monday. And then the announcement you've been waiting for, our AirPods winner today goes to Sandeep Chowdhury, Senior Software Engineering Manager at LiveRamp. That's a customer. Congrats, Sandeep. Thank you for joining. If that's not you, don't give up. We are going to announce one more AirPods winner by the end of the day for anyone who has tried out this movie recommender spaces that we've shared. You can find that in the chat. We will also be emailing out a link to that today in your email in the next maybe hour or two. So keep an eye on your email. Good luck. Hopefully you're the next AirPods winner. Thank you to everyone for joining. Thank you, Madhukar, for an awesome presentation. And thank you to our audience. Have a great weekend, everyone.
Thank you.
Bye-bye.